Hello, so in this video we're going to talk through some product rule questions. So let's have a look at differentiating this. Y equals e to the power of x times by x squared. So just notice first of all, what are my two functions? Let's start off by identifying that. So my first function is e to the power of x. I'm going to call that u. My second function is x squared. I'm going to call that v. So just remember that the derivative of a product of two functions, okay, so if I want to differentiate two functions being multiplied together, so in this case u times v, so my u function is e to the power of x, v is x squared. Then just following the formula, I know that should be equal to the derivative of the first function multiplied by the second function left alone, added to basically the same thing but just the other way round. Okay, so the first function left alone multiplied by the derivative of the second function. So let's have a look at this. Okay, so I've got y equals e to the power of x times by x squared. Well, my u function is e to the power of x, okay? So therefore, if u is equal to e to the power of x, then that means that the derivative of u must be also equal to e to the power of x, because I know the derivative of e to the power of x is e to the power of x. Now my v function is x squared, which means that derivative of v is going to be equal to 2x. So now if I take this and put it into my function, that effectively means, or put it into my rule rather, that effectively means that dy by dx should be equal to, well, derivative of u is e to the power of x, multiplied by v, which is just x squared. Plus, let's have a look, u times by the derivative of v, well, u is e to the power of x, derivative of v is 2x, okay? So therefore, I could write this just ever so slightly, I'm going to write this as 2x e to the power of x rather than the other way round, doesn't really matter, but that there would be the derivative of my function. Okay, so nice and easy. All right, let's have a look at another one. Let's have a look at this one. So y equals cosine of x, all multiplied by x to the power of 4 minus 8x plus 3. Okay, so let's first of all think about what u is and what v is. Well, u is my cosine of x, so u is equal to cosine of x. Okay. My second function being multiplied, so my v, if you like, is the x to the power of 4 minus 8x plus 3. So let's work out what the derivative of these two functions are first and foremost. So the derivative of cosine of x, well, just think about my circle. From a cosine of x, move clockwise around my circle. The derivative of u has got to be negative sine of x. If my function of v is x squared, x to the power of 4 minus 8x plus 3, then that means the derivative of v has got to be 4x to the power of 3 minus 8. So now I'm in a position where I can actually just put this straight into our formula. So therefore I'm saying that dy by dx should be equal to, well, it's u multiplied by the derivative of v, so that's cosine of x, multiplied by the derivative of v, which is 4x cubed minus 8, plus the other way round, so it needs to be v times the derivative of u. So that's going to be, well, the derivative of u is negative sine of x, and v is x to the power of 4 minus 8x plus 3. Now, to be honest with you, you could kind of faff around, you could try factorising and making it look a bit simpler. To be honest with you, I'm fine if you wanted to leave it like that. All right, fine. Let's move on to a slightly trickier example then involving the chain rule as well. So let's try f of x is equal to the natural log of 4x to the power of 5 minus 8x, all multiplied by the sine of 7x minus 5. Okay. So let's first of all identify what is u and what is v. So I'm going to write it down underneath instead now. So if this is u, so my u is equal to the natural log of 4x to the power of 5 minus 8x, then this must be v. Okay, so this must be v. So my v is equal to sine of 7x minus 5. Okay, cool. So that means then if I want to differentiate u, I'm going to use the chain rule. So just remember, outy-inny rule. So differentiate the outside. So my outside function is my natural log. Derivative of natural log is 1 over that function. So it's going to be 1 over, and in this case my function is 4x to the 5 minus 8x. Then I need to multiply all of that by the derivative of my inside function, otherwise the derivative of my 4x to the power 5 minus 8x. That's going to be 20x to the power 4 minus 8. Okay. If I wanted to tidy it up slightly, I'd end up with 20x to the power 4 minus 8, all divided by 4x to the power 5 minus 8x. And yes, I know that you could probably cancel off a factor of 4 in each of those things, but I'm just going to leave it as it is at the moment. Okay. Now if I deal with this thing, so the v equals sine of 7x minus 5, then that means the derivative of v, well, the derivative of v, first of all, I've got two functions. I've got a function within a function. So let's first of all work with the sine function. Let's try differentiating that. Derivative of sine, of course, is just cos. So it's going to be cos of my function, which in this case is 7x minus 5. Okay. Then I need to multiply by the derivative of my inside function. Derivative of 7x minus 5, that is just equal to 7. Okay. So therefore, the derivative of v is going to be 7 cosine of 7x minus 5. Okay, fantastic. Now I'm in a position where I can actually use my formula to work out what the derivative of my original function was. So it's going to be u multiplied by the derivative of v. So u is equal to the natural log of 4x to the power 5 minus 8x. Okay, multiplied by the derivative of v, well, that's 7 times by the cosine of 7x minus 5. I'm going to pull the 7 all the way out the front. And I'll just end up with the cosine of 7x minus 5 at the end there. Okay, it doesn't really matter because it's multiplication. I'm just doing it in a slightly different order to make it look a bit prettier. Then I'm going to add that to the other way round. In other words, v, which is equal to sine of 7x minus 5, multiplied by the derivative of v, which is that fraction there. So it's going to be multiplied by 20, x to the 4 minus 8, all divided by 4x to the 5 minus 8x. Okay, so there you go. So that would be the derivative of that function there. Okay, it's just simply following the formula in the right way. Okay. Now finally, let's have a look at this function, which is very much chain rule and product rule kind of integrated together. Okay, so let's have a look. So f of x is equal to sine of x cubed plus 5x, all multiplied by e to the power of x squared cosine of x cubed plus 8x, like so. Okay, so let's first of all identify u and v. So u has got to be equal to the sine of x to the power 3 plus 5x. And the v function is this thing here. So it's quite long. So v is equal to e to the x squared cosine of x cubed plus 8x. Okay, so let's first of all differentiate this. So if I want to differentiate u, well, first of all, I've got to differentiate the sine function. That becomes cosine. I leave the inside function alone, so the x cubed plus 5x, leave that alone. Then I need to multiply that by the derivative of the inside function. So the derivative of x cubed plus 5x, that is 3x squared plus 5. Okay, so now let's find the derivative of v. So this is going to be same kind of idea, but it's just a little bit longer because there's more functions within functions going on. Okay, so let's write down here. So first of all, what's the derivative of an e function? Well, derivative of e to the power of something is just e to the power of something. So e to the power of x squared cosine of x cubed plus 8x. Now have a look. I now need to find the derivative of x squared times by the cosine of x to the power 3 plus 8x. Well, that in itself is another product rule question. Okay, so if I just quickly find this, if I want to find the derivative of this, first of all I need to differentiate the first function, so 2x, leave the other function alone, so the cosine of 8x, cosine of x cubed plus 8x. Then I need to add that to effectively the same idea but the other way round. So in other words, this time I leave the x squared alone, and then I multiply it by the derivative of the other function. So here I've got the derivative of cosine of x cubed plus 8x. Derivative of cosine is going to be negative sine of x cubed plus 8x multiplied by the derivative of the x cubed plus 8x. That's going to give me my 3x squared plus 8. Okay, so literally I've just used quotient rule and product rule together to work out the derivative of that fraction has got to be equal to this thing in green. So that's what I need to multiply by the thing in blue. So in other words, all of this multiplied by 2x cosine of x cubed plus 8x minus x squared sine of x cubed plus 8x multiplied by 3x squared plus 8. All right, fine. So it's a bit long, but hopefully the method makes sense to you. Okay, so now I'm in a position where I can actually differentiate my original function. So let's find the derivative of my original function. So I'm going to first of all take u, which is sine of x cubed plus 5x, multiplied by the derivative of v, which is this big, long, horrible thing here. So actually, I'm just going to copy this down because I'm too lazy to write it out again. So I'll just copy and I'll paste. Okay, the advantage of doing this on a tablet rather than having to write it by hand. And in fact, I will just change it to black to make it look as if I haven't just copied and pasted it. There we go. Okay, then I need to add it to, so I need to do it the other way around now. I need to add it to, well, let's take v now, which is my e to the power of x squared cosine of x cubed plus 8x, multiplied by the derivative of u, which is this thing here. So I will write it out, I'm not being lazy. X cubed, cosine of x cubed plus 5x, and then I'm going to multiply that by 3x to the power of 2 plus 5. Okay, so it's big, long, horrible. I'm not even going to try and simplify that, but that is the derivative of that function.